Cool. Hey, folks on the live stream. This is Joel. We are just slowly getting started today. So thank you for joining us, GDG team, and anyone from the CNCF community. Just showing you there are people here. So, yay, fun time. So we'll be starting soon. Just hang tight. We'll grab a soda, grab something to eat, and we'll be right back. Hey, live stream folks. We are hopefully kicking off here soon. I'm hoping you're hearing me right now. So, just getting the last few people settled in here in person, and we will get it started here soon. So, again, grab some water, grab a drink, grab some food, and we'll probably start here in 2 minutes. So, thank you. One, two, 1, 2. Test, 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 test. We got to be courteous to our folks on the live stream, you know? So, my co-presenter's probably on the live stream. So, here you go, Josh.
Okay. All right, thank you so much, everybody, for joining us here. Great to see so many folks, new faces, old faces. Definitely one of the top goals of this event is just bringing people together, helping the Chicagoland community, developers meet each other, strengthen our community. Before I turn it over to the people you really want to hear, the technical talks and ideas, I just wanted to share a little bit about the group, a couple other public service announcements. So and there's that link. I'll post it again. So first of all, good thing I put it aside. I don't want to forget. Thank you so much to the Aspen Group for sponsoring us. It's a great venue and great partnership with Joel. Thank you to Red Hat for sponsoring me and the other folks that are putting this stuff together. So I'll give a shout out to them too. And the Cloud Native Community Foundation, Cloud Native Computing Foundation. I thought it would help to just real quick go over the goals of the group so people understand what we're here for. We want to build relationships, help everybody facilitate building relationships with folks. We want to help you all know what's the latest and greatest in the cloud native world. We want to help Chicagoland companies and vendors here learn about developers' needs, recruit developers. And we want to build Chicago's prestige. We got 10 million people here, a lot of developers and architects. We can get Chicago more on the map. I don't want to miss the chance to solicit more contributions or more help. We can always use more help. If you present, you can gain experience presenting. If you help organize some of the events, you can gain some experience with leadership. You get a chance to build your network here. These are other things that I already said. Share your projects. We don't like product pitches, but what does the group do? So we hold these meetups, which our current goal is to try to have one a quarter, but maybe we'll become more frequent as we get some momentum. We occasionally have online meetups. I'll put up a QR code so you can join our Chicago channel and join the official CNCF group so you get notified of stuff that we're doing. We try to hold planning meetings. Those sometimes get attended, sometimes don't. But I try to be open about it and gather input, feedback from everybody. So join the group and we'll notify you about those. We're always looking for support. If you could host an event or your company can host an event, if you can sponsor food or drink at an event or bring swag along for everybody, let me know. You can reach out to me somehow. I didn't put it up here. You can just search for me online, send me a LinkedIn, or you can go on the CNCF Slack and find me there, Josh Gavant. We're always interested in presenters, so let me know if you want to present. And here's these. I'll just leave these up for a second. That first QR code, and I'll figure out a way to share the deck on the Chicago chat, so it's kind of an inception problem. But if you join the Chicago chat in CNCF, Slack, which you can get an invite at slack.cncf.io. Then you can join our Slack channel there, and we try to keep people updated on things that are happening. And that's the community. You'll get emails about future events and asks for feedback about this one. Before I turn it over to the speakers, I just wanted to share some upcoming events that we got in the area. First of all, I know that the Google Developers Group, I'm just going in time order, but the Google, in date order. So the Google Developers Group, run by Joel, is having an event on October 11th, I think at Google, just a couple blocks away from here. We're going to try to hold another one of these events the week before KubeCon on Thursday night to get everybody excited in the spirit, or if you're not going to KubeCon, to let you, enjoy the spirit anyway, because it'll be free. We're working on that now, and we're working on one for post-Thanksgiving that week as well, so even more than quarterly. We really would love to do like a KCD, Kubernetes Community Day, next spring, but we're going to need help to organize that. So let me know if you want to. A couple other things coming up. Red Hat is having a Summit Connect on October 24th. That means it'll be an event where we talk about our products. I won't go any further than that because no product pitches, but you're welcome to come. There's Cloud Native Reject is a popular, if you're not going to KubeCon, it's much cheaper than KubeCon. It's the days before, the weekend before. The CFP is still open, so September 12th, Monday it closes. OpenShift Commons is going to be the day before KubeCon, actually right across the street here. So It's another free event. You can come. And then, of course, the pièce de résistance, the KubeCon at McCormick Place. It's going up in price tomorrow, $500 more. Right now it's $1,500, but this will get you 15% off, KCNA 23 meetup. So sign up tonight. And yeah, so today, now we'll get to the good stuff. We've got two presenters going to present about, you got a Kubernetes cluster, what are you going to do with it? So with that, let me turn it over to my friend and colleague, Chris. Take it away. Oh, yes. Well.
How's the sound? Testing. Well, hey, thank you for being here today. I'm excited to be presenting to you all. Today we're going to be talking about mastering the post-provisioning phases of Kubernetes. So a little bit about myself. I'm a Red Hat cloud architect. I've been with Red Hat for 5 years now. I was part of our central team, mainly working with companies here in either the Chicago or Detroit area. The last 2 years, though, I've been more national, focused on our cloud managed services, so things like our ARO and ROSA. I specialize in large-scale container-based migrations and modernization, which is some of the things I'll be talking to you here today. And I've been involved in container technology for a while, actually. I had the privilege at Purdue University while I was studying there to work with the Department of Energy on a early containerization project for the Titan supercomputer. So I worked with Purdue for a couple of years, and then I actually spun that off into its own business startup for about 3-4 years, working with the Department of Energy exclusively. So I got a lot of early insights into the container technology. So if anyone's familiar with OpenVZ, that's what we were using at the time. So this was pre-Docker. I'm also an advocate for Conveyor. Conveyor is a CNCF project around migrations, specifically doing analysis of migrations, which I'll be talking a little bit here today. And then I've spoken at quite a few CNCF events. So I typically am a regular at KubeCon, and I'm part of the speaker events for quite a few of those conferences. So just a quick summary of what we'll be talking about today. I'm going to be talking about 3 phases of day 1 operations. So when I was approached to make this talk about what Kubernetes is up, now what, the first thing that kind of came to my head is just day 1 operations. It's typically the term that we use when we're trying to get things deployed, figure out what we need to configure, and how do we get an application to be production ready. We'll be going through these 3 different phases. We'll talk about different types of best practices for migrations and what the Conveyor tool can help with that. We'll talk a little bit about the deployment phase, and specifically around that, how you can use GitOps to actually leverage a lot of advantages to that deployment, and some of the methodologies and challenges that come with GitOps. And then lastly, I'm going to talk about scaling. I did see that the talk right after me is actually going to go much more in detail about this. So I'm going to glance over it and then hand it off to the next speaker, who's actually going to be going into this subject a little bit more. So you'll get a pretty in-depth look into a lot of the different technologies and methodologies for multi-cluster management. So typically, when we're talking about day 1, you'll see a pattern form where we're starting with a migration of some sort. It could be refactoring, it could be replatforming, rehosting. There's a few different types of migrations. but this is usually where people are starting. The majority of the time when I'm working with people, they're bringing existing applications into Kubernetes or some type of application that they're just starting out. So usually there is some form of migration going on in this phase. And then deployment, where we talk a little bit about like CI/CD and GitOps and how that can fit in, and then how you can then scale that out to multiple clusters. Now I want to highlight something with the GitOps here. Sometimes GitOps is used in day 0 to actually provision your cluster. I'm actually not going to be talking about that today, but just know that GitOps can be used both from a application deployment side, but it can also be used to actually manage some of your infrastructure like operators. And it's very useful in conjunction with something like an Ansible for provisioning. So typically when we're talking about migrations, there's usually this analysis phase. And one thing I wanted to highlight here is this is extremely important. And what I find with most organizations I work with as being a migration specialist is that people are not spending enough time in this analysis phase. They think, oh, my application runs in a container locally on my machine. I'm sure it's good to move into Kubernetes. This is very often not the case. I'll be talking a little bit about the tool Conveyor and how that can be used to help with this phase, and some of the lessons learned here in a moment. Refactoring, this could also be rehosting, replatforming, really depending on how you're moving your applications into your cluster. I'll talk a little bit about move to kube and some of the advantages of this product. I'll talk about that when we get to the GitOps portion here. And then just executing on that migration. I'm not going to go too much into this because this could be a whole presentation on its own, but just know that the 3 major things when you're executing on a migration is having wave planning. So when do we move this application A and application B and application C? And that becomes very much a people problem. Way more than a technology problem. How do we do cutovers? And then how do we use sunsetting of existing infrastructure after everything has been moved over? So a lot of the different mistakes I see organizations make, I was kind of hinting at it just a moment ago, and it's just not understanding your application and what it's required to move into something like Kubernetes. The example that we ran into a lot, especially a few years ago, was organizations who were already running microservices, but they're running like the Netflix Eureka stack and service discovery. That doesn't play well with Kubernetes, and you're really just making a lot of redundancy. That's an example that we ran into quite a bit, a little bit less now that that's not as popular, but that gives you an example that there are some existing libraries that may not be as friendly for something like a Kubernetes cluster. And one of the biggest mistakes that I see is just overlooking data gravity. And I go into these meetings, when people are starting to plan out these migrations, and I'll ask about data gravity. And so many times they're like, no, we don't have any data gravity. We're good. I'm like, really? Are you sure? And they're like, yeah. And then sure enough, like 9 times out of 10, we run into some type of data gravity issue during the migration. A lot of times it's that the infra team is not even aware that there is data gravity for some type of service that's being used or some type of mainframe that is being accessed that they're unaware of. So always keep data gravity in mind. Data gravity is something I could have a whole talk on. So again, I'm just brushing over all these subjects. But do let me know if you have any questions in this area, because this is an area that I work pretty heavily in. And then missing critical security and compliance requirements. I always tell people who isn't in the room. So the first day that I meet with customers who are migrating into typically a cloud-based Kubernetes platform, I say, who is not in the room right now? And that typically is there a compliance person that's not in the room? Is there a security person? And So a lot of times, well, that person doesn't have to sign off on this. We're good. We have a clear lane. That is probably just as much as data gravity, if not more, the biggest thing that I see derail cloud native projects. I've had multi-million-dollar projects just completely go off the rails because of compliance. Because someone comes around and says, actually, you can't do that because of this certain requirement. So always, always, always keep these things in mind. And like I said, who's not in the room day one? I was kind of hinting at this earlier, but cloud native migrations are just as much or more a people problem versus a technology problem. Like I said, it's usually things like compliance, security, the lack of communication. We've got one infra group over here and another one that relies on something over here and that hasn't been communicated. For a cloud native migration to work, it has to come from the top, and everyone needs to be bought into it, even if they assume that they are not part of it. Because you'll eventually find that a lot of people actually do need to be involved who you otherwise would have thought didn't need to be there. So always be thinking about the people who need to be involved, and that this is just as much a people problem as it is a technology problem when we talk about migrations. So I'm just going to give a very high-level overview of what Conveyor is. You can search my name on Google and type in Conveyor. I've done a few talks on Conveyor, or you can also go to conveyor.io if you want to actually see some demos or learn a little bit more in depth of what the product can do. But this is an open source CNCF project. It is focused on the analysis of applications. So you can point to either your Git repo or upload some type of artifact, packaged artifact, and it'll do an analysis of both your application and then any of your dependencies as well, and then give you a score on the level of difficulty of, based off of experience of other experts in the migration field, what is the level of effort to solve this particular issue. So we can actually find some things with data gravity. IBM Research is very involved with the Conveyor project right now, and they're focused quite heavily on this issue of data gravity. So there's already some of that there, but like I said, it's constantly evolving. But it can also show things like I said about like Eureka for Netflix and a host of things. I think there's, all in all, there's a few hundred different things that it's checking. Right now it's focused around mainly Java, but there's also some .NET work being done as well that you can see in, I think, preview right now for some of the newer versions that are coming. So some of the new features that also were released this year is wave planning. So I mentioned wave planning earlier. This is where you actually schedule out your migrations. This guy needs to go first because it's dependent on this, or this particular group has a freeze for some reason, and they need to wait for 2 months. And it takes all that information and allows you to manage your migrations through the tool based off of the analysis phase of with all the information that it produces. So I highly recommend Conveyor. It is an awesome tool, and it's very good for these types of migration analysis. Deployment phase. I'm going to focus mostly on GitOps, but I wanted to highlight a couple of things. A deployment, it doesn't have to just be GitOps, and a lot of times it's not. There's a lot of people who are doing Tekton and Jenkins in a traditional CI/CD tooling fashion. And there's even some people, which I wouldn't recommend doing this exclusively for applications, but there's even some people doing automation platforms for this type of work, or even like a shell script. Again, I wouldn't recommend that, but I wanted to highlight that these are some of the common patterns that we see in industry right now. And these, all three of these can work together as well. So you're not limited to just using GitOps. Very often what I see is people have some type of automation that's happening here. Maybe it's setting up some type of user service in the back end on your cloud provider, and then handing it off to something like an Argo, which is making sure that all of the artifacts that need to be present are there. And then in Argo, you would then have something like a Tekton kickoff, some type of deployment based off of something that was stored here. So I'll talk a little bit more about these patterns, but I wanted to highlight that these are not exclusive from one each other. You can actually use them in conjunction. GitOps is not just a technology, but also a methodology. So this is what I usually open up with when I'm talking to customers who are interested in GitOps. And one of the things I tell them first is, hey, GitOps is awesome. It's very powerful and can be very useful for your organization. But if you don't treat it like a methodology, then it's typically going to fail. And by that, I mean you have to understand what the process of GitOps looks like to actually utilize the technology, which I'll talk about here in a moment. So 3 of the GitOps mistakes that I see. Thinking it replaces traditional automation. I was hinting at that a moment ago, especially in more the infra side as well. These technologies really complement each other, something like an Ansible and a GitOps, an Argo CD. Very often what I'll see is someone will provision a Kubernetes-based cluster with something like Ansible, but then actually seed it with all of the different operators and all the different resources manifests through something like a GitOps. So a lot of times people are like, well, can I just get rid of my Ansible because I have GitOps now? My answer is no. That's something you just need to figure out where that line is in the sand, where you're going from the platform automation into more of a GitOps approach. And it can vary, but one technology does one thing better than the other. And I'll highlight that here in a moment. This goes back to the methodology thing I was talking about earlier, not enforcing your GitOps approach. So I had a client who was in a disaster recovery situation, and they were rolling back a cluster, and things were not working as expected. And after a few conversations with their developers and their different cluster administration people, we realized that some people had been using the kubectl command to deploy a few resources that were critical for their application services that were running. So this is an example where if you don't limit those types of accesses to people, you can have a lot of what we call drift within GitOps. And for GitOps to really shine, you want as close to 100% in GitOps as possible for your resource management, or else you're losing a lot of the benefit of that technology. And then just phasing right into that, when you're not fully GitOps, then you're not having some of the things like audit control. And actually, I think that's my next slide. Yep. You're not utilizing some of the benefits of things like security and audit and disaster recovery. So for security, it's like things like PR requests. You're having basically GitOps becomes your gatekeeper. Who's allowed to make changes to the cluster? And then after that, you have a clear audit of who did make those changes at what time. That's very critical. The people who are most excited often about GitOps when I'm giving these presentations are usually the security people. They're like, this is awesome, because I don't have some terrible syslog that has very archaic messages. I can actually see a commit history, who did PRs, when were these artifacts changed at what time, and it gives a much better visualization of the state of the cluster than just general logs. And then disaster recovery. I had another client who was actually doing much better with their GitOps. They were probably at like 99% completely everything in GitOps. And we had a catastrophic situation happen where one of their whole data centers just went up in smoke. And it was completely gone. They had a cold configuration, an empty cold Kubernetes cluster available, but there was nothing deployed on it at that time. So we were able to use GitOps and just switch it over to be pointing to that with that cluster to the Git repo, and they were up and running within 12 hours. And their SLA was 24. In the past, with their other platforms that they had used, this is something that could take 2, 3, 4 days. So very often they were going over their SLA, and we cut that down in half just by moving to GitOps. So always be thinking about the functionality that comes with GitOps when you are utilizing it fully. One of the analogies I like to make is that GitOps is, like Ansible, for example, is more of like the blueprint of a house. It doesn't change very often, and you want to get to a very particular state and then stay there. There's not a lot of, you usually don't want to change your house too much. Where GitOps is more about managing the furniture and the appliances and all the things that go in your house. These are things that change often, and there may be times that you change it and you want to go back to a particular time in history, where using traditional automation like Ansible, that's a little bit harder to do, where with GitOps, it's very easy to go back to a point in time and remember, oh, hey, this is how I had this furniture configured at this time. So like I said, these technologies complement each other. I'm highlighting this a lot because this is a question I'm getting a lot right now in the industry of like Ansible versus GitOps. This is actually something I worked on with a customer recently. So I wanted to give you an example of some of these technologies working together, where what they wanted to do was handle all of their deployments through GitOps by using Tekton. But they didn't want to manually be adding pipelines to the Git repo. They wanted it to be all automated. So when a PR was committed, everything was done automatically. But if they needed to, they could go back and find the artifact for the pipeline. The way we actually solved this for them was setting this up as a GitHub Actions on PR approval. And then we actually generated the pipeline. The reason why we were generating it was because there was some additional information they wanted there. I know there's ways that with the pipeline you could just have it there and change like a tag on it. But they wanted to have an actual artifact for each one of their deployments. And then one of the, for this company, it was a healthcare company, a big part of this was Tekton chains. I'm not talking about that today, but absolutely check out this project. It's amazing. It's focused on zero trust pipelines and tagging all the artifacts. So it tags your pipelines and also tags the images and then stores it into a SIG store. So all of that then gets stored in the container registry. And then anytime there's a deployment, in our case, we were using Caverno, but there's a few different policy engines you can use. I'm going to briefly touch on that here in a moment, and I think there's some more policy conversations coming up in some of the other talks. But there was a policy set within this cluster that only images that were signed by this cluster are allowed to be deployed in this namespace. Because this namespace in particular was very sensitive and had a lot of PII in it for this healthcare company. So give you kind of an idea of how some of these technologies can be used together. And then if you're interested, Argo is probably the most popular of the Argo CD, most popular of all the different GitOps solutions. There's a few others out there that I think are good, but this is the one that I typically use with my clients. Now we're going to talk about scaling. I'm not going to touch on this too much since the next talk is actually going to be going into this more, but I'll go over how that fits into some of the things I've been talking about up to this point. So probably the most popular for this is open cluster management. Now, I specifically have not used this open source tool. I've used the downstream for Red Hat, which is ACM, but the functionality is quite interchangeable. So if I'm talking about ACM, a lot of the functionality exists within the upstream open source project, OCM as well. So some of the advantages of using OCM is just being able to centralize the management of your clusters. So 2, 3 clusters, yeah, you could probably get by on that. But once you start getting into 10 clusters, 20, 30, 40, 100, this is where things really start to fall apart. And even traditional automation like Ansible and GitOps still can make this very difficult to manage across this many clusters. So this is where these tools really shine, and they bring a few different functionalities. The one that I use the most, because of my specialty, is more about enforcing multi-tenancy. There's policies that you can create with these tools. Caverno is one that I've used before, but then OCM and ACM also have their own ways that you can implement those policies. And these policies enforce things like, what is your namespace named? Does it have a particular tag saying what team owns it? Do you allow, like the example I gave earlier, what images are allowed to be deployed? Do they have to have a particular signing? Do they have to come from a particular registry? These are some examples of policies that you can implement. I know Caverno alone has hundreds and hundreds of just these already built out. You can go to their website and see quite a few that are available. So if you're interested in getting more into this conversation about zero trust, definitely check out OCM or ACM. They do a great job for this and allow you to then deploy those policies across all of your clusters, which is the critical point here, where otherwise you're going to be managing a subset. And then automation. This is an area that then you can kick off automation towards all of your different clusters. So this could be something like GitOps. It could be even an Ansible script. There's a lot of ways that you can incorporate things like automation into this multi-cluster management process. And I think, like I said, I believe the next talk is actually going to go more into some of these subjects. This is a diagram that I typically use with clients just to kind of give the general idea. This architecture is typically called hub and spoke. The idea being that there's a central hub, and then you have all these different spokes. This model actually, from an engineering standpoint, actually came out of the airline industry, how they do a lot of their hub and spoke. So things like actually O'Hare here, Atlanta, that is an example of a hub and spoke, where that's the hub of that airline, and then they can easily reach out to really any place in the world by 2 flights by having enough spokes to get their clients where they need to be. The idea is similar here, where we have a centralized place where things like security, GitOps, automation, provisioning, policies, all can be managed and then spread out all to your different clusters. This is also very critical when we start talking about multi-cloud configurations. So here I actually have an example of a multi-cloud configuration and something like a Submariner to make this very easy, where you can connect between different environments. It could be even an on-prem here, depending on your security requirements. This is more of a technical diagram that gets more into the nuts and bolts of how this looks. Here you'll have a Git repo with your different policies and your application definitions for your Git. That's then being consumed by, in this case, it's OpenShift GitOps, since this was a Red Hat specific implementation, but like an Argo CD could be used. I mean, you can say here it's an Argo. And then it then manages through the ACM to push out the different requirements to this other cluster. So this gives you kind of an idea of the different namespaces and the different technologies involved in this process, pushing out different changes to your clusters. All right, that's it. I wanted to give you just a quick primer of a lot of the technologies we're seeing right now in this day one operations landscape. And I'm open for any questions. In the back?
You broached the topic of where infrastructure automation, where does that end? And where
Yep.
does GitOps begin? Can you go a little clearer?
Yes, sure. This is a really good question. And a lot of the issues come with the chicken before the egg problem with GitOps. There's a lot of things that need to be usually present for GitOps to work appropriately that would then create circular logic if you're trying to put that within your GitOps repo. So typically, what I do is I'll have, in my repository, I have my folder, which is what actually is going to be implemented in Git of the GitOps. Then I'll have another folder called a cluster primer. And this includes things like like the external secrets operator, the GitOps operator, and then some of the different permissions and configurations that need to go around those. Because it actually takes a decent amount to get GitOps up and running, and the chicken before the egg problem is usually where I see people get stuck the most. So, so typically what I recommend is like an Ansible or a Terraform, which is actually doing the provisioning of the cluster, but then you have a priming phase as well, which that will use something like a kubectl or use the API to actually deploy some of these artifacts. Once that's up and running, then you have an opportunity to then deploy the different operators and the different configuration manifest files that make up your infrastructure for that cluster. So that's, in a nutshell, that's something I could have a whole talk on, but it's trying to decide where does that end. I come from more of an applications-based background. So for me, I want as much into GitOps as possible, and I want the Ansible to end as early as possible. There are other people I know that are on the other side. They want the Ansible to go as far as it can before it no longer makes sense.
So it's considered overlap.
Yes, there is a point in here where those two meet, where there is some wiggle room based off of your comfort level. The only thing I would recommend is I wouldn't want GitOps provisioning clusters per se, unless it was through something like an OCM that's already been stood up. Or I wouldn't want Ansible deploying my applications, because as I was talking about some of the advantages of GitOps, you lose out on a lot of things that you would get from having a GitOps methodology and technology involved in the life cycle of your application. Yep.
What are some of the strategies you've seen successful for data gravity? Other than the obvious, split up your cluster and make the data center next to you.
That comes with its own problems too. This is a good question. It's that kind of old saying, how do you eat an elephant? You know, one bite at a time. It's typically, usually the news I usually have to break with people.
Has this ever been not a painful experience for a customer? Like
I have had clients who have made it as least painful as possible by using best refactoring practices. A lot of times those organizations have already been going through a kind of a DevOps cloud native transformation within an organization, and they're already moving to microservices and trying to split up the different domains of their data gravity. The problem that you run into is when PII is involved, or certain data that's embedded into the database that cross-pollinates. So there might be things like an email service, for example. Normally that's something that you think, oh, that's a domain I can pull out very easily, make it into a microservice. Well, in that service, there's something that's pulling down PII based off of the email. May not even be using it, but it's pulling it down, and it's available, and which gets flagged either by a compliance or an audit, something along those lines. So it's a very delicate process. It depends on how far they're already involved in that. With PII though, this is typically where hybrid cloud then comes into play.
Do you see more folks sucking it up and migrating their data to where their target state architecture is, or do you see more folks standing up their clusters in their data center?
I'm seeing more organizations biting the bullet and paying a lot of money to have their own private cloud or HIPAA compliant cloud instance on Azure or .gov instance. And yeah, it just depends. It depends on the personnel and how ready they are to take on that mindset of DevOps and having more of a microservice type of approach to their application development. Yep.
All right, thank you, Chris. That was. We're going to take a quick break, 3-minute break, get you something on the side.
kind of what you were looking for?
Yeah, it's great. Thank you.
Yeah, no problem.
Appreciate it. I'm worried that it's focused more on observability and cluster management, but we'll see how it goes.
Oh, that's fine.
He just deferred everything that he didn't want to talk about to you.
Right.
He knows.
You didn't even hear, so.
I gave enough of it that they got the gist. If I knew you may go different directions with it, so. But I didn't want to sit there for like 15 minutes talking about these technologies. You're talking a lot about the advantages of it. Are you going to plug in?
Test, test, test. Test, 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 test. Yep, yep, yep. Cool, cool, cool. There we go. We're good. Dope. So folks are just grabbing water in the bathroom. We'll probably start here in about 3-4 minutes. Yeah, see you soon. Don't think so. Yeah, I think so. What do you think now? Yeah. Do you want to start now or do you want to wait? Alrighty. Yeah, let's start it up. Hey, everybody. Hope, yeah. So let's get started, everybody. Hey, thanks. Great presentation. Thank you, Christopher, for that. That was awesome. So I have a lot to live up to because he said there's a lot of content that he's looking for. So this is going to be a quick little lightning talk about some of the things you're going to probably want to see when you start talking about more than one Kubernetes cluster. So kind of to start, I do want to call out, I've not really been using generative AI too much, but I kind of asked for a boat with Grafana dashboards on it, and all this like slide was generated by it. I was like actually pretty impressed. So pretty cool. So the hype is real. So quick shout out, I just want to give a shout out to my employer and the company that let me do this kind of crazy talk and give us the opportunity to do this crazy stuff. Thank you so much, Tag, for hosting us today, and really appreciate it. Thank you for always being an ally of the community. So there was supposed to be someone else here today, but children will be children, and if they fall ill, they have to fall ill. So Lin is unfortunately not with us today, but a lot of the content was driven by him and his team, so I'll be kind of taking lead here today. My name is Joel Vasallo. I'm the Director of Platform Engineering. There's my X handle if you are interested. So Kubernetes kind of came about as a way to solve for, a lot of the complexities in terms of running your container. So a lot of us turn to it to essentially figure out how to balance our traffic across multiple nodes, across multiple data centers, across multiple areas. But what about when it comes to multi-region? And I think that's where I think Kubernetes can really shine. Out of show of hands, how many people here run more than one Kubernetes cluster in production? Okay, that's a good number. Cool. Yeah, so that's smart because it's also very complex. So, well, first off, I don't really have to talk about it, but why Kubernetes? At the end of the day, container orchestration and management gets a lot simpler. Right, back in 2015, 2016, when we were all learning Docker and starting it, we were figuring out how to boot up VMs and start this up, and then Swarm was around, and then there was different ways of doing it. Really, this kind of became the de facto way. Awesome. Thus, because it came so simple, scaling and load balancing also came with it. On top of that, centralizing the config management, namely around something declarative like YAML, as fun as it is, as Lin would have joked, yet being a YAML engineer is a real symptom of learning Kubernetes if you're not careful. Standardized APIs, and it's not just standardized APIs in terms of how to deploy, but there's also standardized ways of getting metrics from your environment. And it's great because we're all working essentially, all of us are probably working at different corporations or working on different projects. And no matter what, the tools that we're using are typically the same. And because of that, we can all essentially kind of learn from one another. And then quickly, you can also establish onboarding standards too. So things like admission controllers, like it must be named in a specific way, something simple like that. The image must be signed in a specific way. I'm not going to go too deep into admission controllers and OPA today, but I did want to give that as a call out today. So a good chunk of us are probably in a 3-node kind of setup. That's kind of the bread and butter of most cloud providers, especially if you got a one-on-one Kubernetes. And that solves it. So typically, they like to balance it across 3 availability zones. In the event that one data center has a critical failure, you can still operate with relatively good success. Kubernetes' control plane will know that, hey, my workloads in, for example, A will now move over to B, assuming there's enough space, and reschedule the work until A comes back, and then it'll kind of reshuffle back. Until there's a regional failure. What happens? Just to show that I am equally calling out every cloud provider, stuff happens. It is not a fault of a cloud provider being down. It's the fact that application engineers and infrastructure engineers don't consider regional failures. A lot of times in our data center paths, we've considered the fact of DR. Cloud does not solve that for you. That's still your responsibility. So at the end of the day, why did USC 1 go down and your entire website go down? Start considering that maybe you need to have resiliency at multi-region as well. Because it is going to happen. Everything breaks all the time, as Werner said from AWS. I like that quote a lot. I'm not going to go into a vendor speech, but kind of giving you an idea as to how we do that. We typically run a global load balancer inside of Google. It makes it extremely easy, gives us the ability to spin up multi-cluster, and through one of their management APIs, unfortunately, it's closed source. It is not something like container management engine, open cluster management. It is using essentially a GKE hub. It essentially allows us to manage multiple clusters in multiple regions. But that concept is not just a Google thing. You could find plenty of open source alternatives to that kind of concept. So great. We have regional availability, but as they say, more clusters, more problems. And at the end of the day, the reality is that monitoring your clusters isn't just about monitoring, the one aspect of logs or metrics. It can go down as far as down to your applications, as far up to your infrastructure, load balancer, how requests actually make it into your cluster. So I'm going to talk about Istio, and it doesn't really come up from an observability talk, but I do think that there are some niceties that it does provide, especially in a world where folks may be in a position of moving legacy applications. You really can't touch them, and all you know is that it takes requests at port 8080, and it shoots requests out to another service at port 8080. So at its core, Istio really is a service mesh, and it helps with traffic routing, as I just alluded, some level of security with MTLS, observability, which I'll talk about, and extensibility, all without having to ask your engineers to add custom code. Recently, Istio was a part of the CNCF community, so I'm really excited to see that they're a part of the community now and kind of working on an open standard, so that's awesome. If there's anyone from the Istio team is watching, thank you. But what I mean by custom code, many times we have a monolithic application, and for better or worse, we have to move that into either a Kubernetes cluster or to some sort of centralized zone or quarantine environment. The problem with that is that touching that can be pretty problematic, right? Like, hey, it's easy, brand new microservice.net, you spin it up. Hey, add Prometheus metrics. Sure, great. This is a brand new app. There's no pressure on this. Well, we added logging to our major application, and it just suddenly crashed because it ran out of memory because it couldn't generate logs fast enough because it's handling 20 million requests. So little things like that become a challenge. So how does Istio help us with that? At the end of the day, it's because it obfuscates communications between app to app through a thing known as the sidecar proxy. By default, it uses a mesh network behind the scenes. This is probably the most well-written way of how Istio works. There's a new way where it doesn't have like a sidecar, but this is the kind of the current model, essentially that you have a service A that talks to your proxy, and in order to talk to service B, instead of you talking straight to the .NET container, you talk to an Envoy proxy which talks to service B. So, and then there's a management tier which you can do a whole Istio talk. I'm not going to talk about that. So you're probably wondering, well, what's the advantage of doing something like that? Well, because I'm no longer having to code my logic into my app on how to talk to another service, I can now say things like, hey, service A, I want 95% to go to version 1 of service B, but only 5% to go to service B part 2, like let's say a canary deployment of sorts. Since we're dealing at layer 7, we can also even take this a step further. We can do user agent routing. So imagine you live in a world where you want to have multiple services like, hey, Android users should go here because this is fine, but there's an iPhone issue and we need to do a hotfix and we don't want to touch the Android base because it's working well. You can do a quick release, route anyone with the user agent iPhone, and send it over to another set of pods. So in short, it gives us fine-grained control over traffic routing with things like routing rules, retries. It also gives you some security with MTLS and access controls. But really, this is a kind of an observability talk. So I've been talking a lot about cool routing services, canaries. We've seen that before. But really, how does Istio kind of enable observability? Well, because all the logs and all your requests are now flowing through that proxy, you have traces, you have logs, and you have metrics from those Istio sidecars that I talked about earlier. And a good way to visualize that is with a tool called Kiali. It enables some real-time visibility within your service mesh. So, as I mentioned, Istio is fantastic. It gives you a way to route your services. It gives you a way to route your requests. But it can be extremely difficult. It's yet another container inside your cluster. You have to figure out things. And especially when you're trusting a sidecar to essentially do all your routing, the sidecar can crash if you're not careful and you don't scale your deployments properly. However, that being said, it plugs into Istio's embedded metrics, logs, and traces to provide visibility. By building service graphs, displaying service health, it generates Istio's current configuration viewable in the cluster. And the best of all, with a lot of the enhancements that have come with Istio, before it was kind of a side deployment, you can still deploy it as a separate service. But if you just want a quick way of seeing it, you could just do Istio CTL dashboard Kiali, and you kind of get an awesome visibility into your environment. So things like visibility into requests per second. You can say, hey, this Nginx box is calling this service 65 requests per second. What happened? See, essentially the tried old true infrastructure of green is good and red is bad. You could probably take a guess as to what's working here and what's probably not. So those red lines up there don't look too good. You can also look at error rates. So as I mentioned, red is bad. We click into this, and then we can see, hey, why is this tossing 62% 5xx errors? We can then start looking at percentiles of over time and look at the request rate. Again, this is all out of the box. Developers didn't have to add this. Just by running Istio, you got this out of the box. Now this one's a cool one. This is one that I personally use a lot, is, hey, outages happen, and typically we know exactly when they happen. We know since 9 in the morning, something happened and it broke. Wouldn't it be great if you could replay that traffic without having to be in that seat and see what actually happened? Because all the metrics, logs, and traces are inside of Istio subsystem, you can replay traffic from a specific time. So in this case, I'm setting that, hey, 8:45, I want to see the 10 minutes to 8:55 in 2-minute increments. And if I hit the play button, you can see a live replay of traffic in your environment as your cluster and your things are scaling. So clicking into one here, you'll see that one of the services was going from 9, 10, 11, 12. You can see the natural increase at 8 o'clock in the morning. And why 8 o'clock in the morning is when most businesses open up. That's us included. And I also don't wake up till 9. So, yeah. So that's kind of monitoring your cluster there. But typically you'll see a lot of mention of OTel. And what can OTel kind of provide with tracing within your applications? At the end of the day, OpenTelemetry is basically just setting up standards and really defining those as kind of standard SDKs and APIs, which allows teams to focus on logs, metrics, and traces, not vendor tooling. A lot of the times we've lived in a world where we have the Splunk agent, the Sumo agent, the Datadog collector, right? This allows you to have an obfuscated way of collecting metrics, and most people are moving to the standardized way of emitting those metrics and logs to then be collected and then forwarded along. And a lot of the tools today are already kind of OTel compliant, so I'll touch into that too. But at the end of the day, tracing really unlocks a lot. So, we were able to see 5xx errors, but if you can take that trace ID further, you can see down to the line of code. In this case, one of our small adapter libraries was having an issue. We're able to go from API gateway down to the microservice, down to the actual implementation and integration of a subsystem and see, well, this timed out after 10 seconds. What's going on? This obviously requires a little bit more instrumentation and requires some development know-how. But in short, showing that just as a magnifying glass, it's you have to kind of zoom in, zoom out, and see your applications from different tiers. I'm going to mention Fluent Bit really quick, because at the end of the day, Fluent Bit is a good way to kind of centralize your logging within your applications. A lot of cloud providers kind of already use this behind the scenes, Google, Amazon. So it's kind of great because it's maintained by the community, and on top of it, it's extremely lightweight and gives you a way to kind of collect from multiple sources and push to multiple outputs. In addition to that, it also gives you the ability to parse those logs before they get sent out to your output destinations. So for example, a very common example, you're scraping a log, and of course we will never log a credit card number, but in the event that a credit card number does get logged, oops, you can have a parser to look for regex and kind of obfuscate that data before it ever lands inside your Datadog or your Splunk or inside of your Google, right? This gives you a way of keeping that data within the bounds of that zone. Don't log credit card numbers. In addition to this, it also allows you to do things like add labels and tags to your metrics, to your logging. So think of things like, I started this with multi-cluster. Your logs, let's say you have app A and app A in cluster B. If you don't really obfuscate that and you just kind of toss it at a kind of collector, guess what? You're not going to know where those logs came from. Great, you're going to see there's a failure, and then you're going to immediately go, well, this 500 error, did this come from East or Central? Right? By using something like FluentBit, you could tag your logs with a cluster environment and say like, hey, this is US East 4 and this is US East 1, right? At the end of the day, FluentBit can sit within your environment collecting those logs, process it, and then again, forward it on to various sites. The main thing I wanted to capture out of here is, for example, you're able to push your logs to S3 and Elasticsearch. But if any of these vendors ever become evil, you can just simply pull them out and send them to another spot. So the beauty of it is you can use this to control your logs and control your destiny. At the end of the day, this is your infrastructure. This is just kind of an example of it in action. You can see that these labels kind of in the green. Sorry if it's a little small for the live stream, but you can see that by tagging, we have our logs in Central and logs in East. And again, the logs are just kind of gobbledygook, but you can see that now we can realistically build a log query. This is using Google, but you can use whatever provider you want. The concept will still be the same, to pull apart that information and then do queries on logs in specific regions, because it will become a problem, especially in a multi-cluster world. So jumping back to the land of metrics, Grafana, I think by now it's pretty well established that Grafana is extremely pretty, and it makes dashboards look great. So it's kind of the de facto standard of visualizing time series data, logs, and traces. And part of the reason for that is their commitment to open source. Again, not really a CNCF product, but I did figure that they are really good custodians about keeping their stuff open, and partially why they became so big. But it also allows you to collect metrics and data sources from various vendors, tools, and products. It's not just anything in Grafana agent. It's not just Prometheus logs. You can take logs from anywhere and kind of see this in one spot, or traces and metrics as well. So for example, in this panel, this is a panel that we use every day, is on the top left, you have Google metrics. This is the Google Cloud metrics. You can use Amazon, Azure metrics, whatever, right? We also have Google logging. That's a log metric being there. We have Prometheus collecting statistics on how many instances we have for one of our microservices, VM capacity. And then we also have the cube state metrics down here. Again, combining a bunch of very disparate data sources and bringing it into one view. And the reason you need that is in a multi-cluster world, no one wants to go to 3 different tools 4 different times because you have 2 different clusters. But charts are pretty, but at the end of the day, what actually powers Grafana? And for us, and for the majority of people, it's Prometheus and the power of metrics. In short, Prometheus collects and stores metrics as time series data. Basically, you have a job that goes and collects standard metrics. This is looking like, yep, this is actually cube state metrics, looking at config maps and labels and info. Key pairs. I'm going to talk about some of the nuances with it here soon, but in short, if you're running Kubernetes, you're most likely, or you're either running or looking at metrics. This is going to provide you essentially the Kubernetes baseline metrics like CPU requests, how many pods, how many deployments, how many ingresses, requests per ingress, things that come out of the box with Kubernetes. In fact, here are some of the things that Cube State Metrics offers. It's a great project, doing things like how many namespaces, resource quotas, mutating webhooks, and cron jobs. Essentially, it's kind of like the collector, or metrics collector that essentially gets scraped by Prometheus. So at the end of the day, how this architecture ultimately looks is step 1, Prometheus goes out to your Kubernetes cluster and says, hey, Kubernetes, you got pods? Yes, I do. Here's a list of IPs. Step 2, it's going to use jobs that you configure, crawl that environment, and collect those metrics from either, it looks like here we have traffic and Redis, and also kubestate metrics and node exporters, wherever those sources may live, and ultimately push that data out if you have an alert. There's a thing called Alert Manager, which I'm not going to talk about today, but that's how you can configure alerts within Prometheus. But ultimately, Grafana can then pull from that time series database, namely Prometheus, and then visualize those charts, and that's when you can do sum and rate functions, and hey, I want to see errors over 5 minutes. You could plot those numbers on the cadence of your crawler. It also requires management, and one of the things that I always like to tell people when they're considering a multi-cluster environment is, have you considered cardinality? Very similar to data gravity, cardinality will kill you one way or the other. So at the end of the day, the labels that you associate with your metric are extremely important for 2 reasons. One, if you're not careful with labels, your queries are going to be slow. Your Chrome browser is going to say waiting, and it's going to crash, and you're going to be like, what's going on? It's because you have too many labels. 2, you're also going to kill your collector environment, because you have to then start appending labels, and you're going to have to start scraping and collecting different endpoints. It's not just taxing on the query side, but it's also taxing within the environment. And at the end of the day, cardinality accounts for how many labels and unique values you have. So I kind of like to show this slide. So this is a good example. On the far left, you'll have a metric, server responses. I don't know if that's a real metric. It's a metric here we have here. Status code, pretty simple. 100s, 200s, 300s, 400s, 500s. 5 labels, right? 5 label values, rather. Another label, environment, prod and dev. You can quickly see that the combinations of both of these labels emits 10 different types of cardinality. Your metric is now a cardinality of 10. What if we had clustered that? What if we had zone? What if we had app name? As you can see, this problem exponentially grows and becomes quite a bit of a problem. If it's not going to be an infrastructure problem, it's definitely going to be a dollar problem, as our CTO knows that Grafana bill can be kind of high. So there are tools out there and dashboards that the community has made within Grafana to essentially visualize your cardinality based on some common. This is a cardinality dashboard. I believe it's the one Grafana Cloud themselves contributed. But essentially it looks at all your metrics, in our case, 1,700 metrics. But there's a total of 1 million some odd series. And how many labels do we have? Around 264. But if you dive further, you can see that, hey, your action label has 791 different values. Well, what's an action? Handle, get, update, delete, post, things like that all start bubbling up, especially when you start considering some of the things that I carefully hid away. Things like controller, like I want to see all the get requests for the hello world function. I want to see all the posts for the account delete function. Things can get really out of hand, and especially, in short, when you're thinking of what can be a cardinal metric, think of things like when you have a URL that has a always incrementing number that's always going to be unique. So commonly like account number. If you're not careful, and especially some of us work at large organizations, we have over millions of customers on a daily basis. You can have 1 million metrics essentially emitted that are very unique. So essentially think of ways to obfuscate that with like $$ account number or something to obfuscate that, and then going back and looking at your logs later. Another thing you can do to help manage cardinality is, we're dropping labels is a good start. I think looking at what labels you want to keep out of a metric is always probably a solid start to keeping it low. But ultimately, in an environment that you kind of want to keep a lot of it and you only want to drop some labels, so things like, I don't need the environment in this metric, drop it from there, and then it'll reduce your cardinality down. This is the easiest way, but also probably the hardest. Another tip is avoid auto-generated labels. We use a lot of us and also a lot of auto-generated metrics. Look at what you're really using on a day-to-day. So kubestate metric ships a lot. Last I saw, it was roughly 17,000, I believe, if not more. Maybe I'm wrong, but quite a bit. Do you really need to know the temperature of the CPU at this time? No, probably not. right? So do you really need to know how many, total request CPUs? Think of the metrics you truly need, get those first, and then add more as you go. Really, I think that's the best way I can always tell people when they're starting their metrics journey. So some takeaways. I kind of flew through a list of services, but figure out how to enable multi-region. Everyone's going to have to do it differently. Look, we use Google. Some folks use Azure. Some folks use AWS. Some folks are on-prem. Awesome. So figure out how to enable multi-region. But that everyone does it differently due to their requirements. We talked about Istio. It's a service mesh, but it also gives you application visibility with low code. Kiali, it gives you ability to take that service mesh and visualize it and also replay traffic. OTel, integrating it into your applications and looking at the metrics that you can emit from your applications. FluentBit for your logging. Look at how you can collect, filter, and route those logs, how you can drop logs that you don't want, how you can remove or add things to logs that you need. Grafana, a great way to visualize it. Prometheus, metrics collection and generation from within the applications and infrastructure. And if anything, more tools, more problems. I did want to give a shout out. We do have a tech blog, so we do some cool stuff from time to time. So feel free to check that out if you're ever interested. It's kind of cool doing this stuff in the healthcare space, kind of pushing the edge on what we can do. But with that, thank you so much for coming to the talk. And that's all I have. Thank you, everybody. Does anyone have any questions before we kind of call it here?
What's the threshold for labels when you start to run it? I started thinking about labels. Trying to do the math of how many different kinds
Your permutations, yeah.
probably have. Like when are you getting into trouble?
Honestly, it depends on how you're running it. So for us, we started with Grafana Cloud, so it was always a matter of how much money we wanted to spend. So a managed service provider, it's you could toss money at the problem, but that being said, not many of us have infinite checkbooks. If you're running it yourself, you'll quickly know because the CPU and memory on your Prometheus collectors will start ever so increasing. Essentially, my rule of thumb is when it starts getting to about 80-ish%, you should probably start looking at your metrics. Because especially that looking at how you implement Prometheus, especially out of the box, scaling Prometheus can be a challenge in itself. There's a reason why folks like Grafana Cloud has done things like Mimmer and Cortex in the past. There's a reason things like projects like Thanos exist out there because it's a complex problem. I would say that I wish I had a magic number of like, hey, no more than 3 labels and you start having a problem. But I think in some cases I've seen, start looking at what you're actually plotting. So like for me, it's always about where am I duplicating data? So the cluster name, for example, typically contains the environment name. So can I then maybe drop the environment name and just look at the cluster name and then do some regex magic in Grafana to kind of derive stage versus prod? Sure, right? I think that's kind of like a pro perspective on that. And but yeah, it's unfortunately one of those things you won't know until you kind of know. Yeah, I mean, plotting it is probably the best bet. Figuring out how you're going to manage your growth early on will probably go a long way, even though early on it's probably going to seem like not important. You're going to have like 20 metrics and you're like, how much can this be? Well, then you give your platform, we hear platform engineering out, and all of a sudden you have 20 dev teams just pushing containers into your environment. Developers. Some of my developers here. But, and then you're like, oh, I didn't expect to have Starlight metrics, and I didn't expect to have .NET metrics, and I also didn't expect to have all the MySQL, MS SQL metrics in the sun on my box. Now I'm no longer at 20 metrics. I'm at 200,000 metrics, right? So start considering that too. And it's also going to be a partnership because especially once you're at the app tier, you're going to have to work with your engineering teams to make some of those changes. Tracking those cardinality specs are going to be huge.
Right, so question about Prometheus sidecars versus Istio metrics. When we're talking about applications and talking about the monoliths, right, with their own logging and their own data streams, as they get
Yep.
all that stuff, would you not then negate, does that negate the need of a custom Prometheus sidecar for, say, for example, MySQL Prometheus sidecar?
Yeah. No, I mean, it depends. I mean, for us, we do it from a point of resiliency. Like, I don't want, and keep me honest if I'm not answering the question. So, we typically keep our Istio Prometheus collectors separate from our application collectors because in the event that the service mesh collapses, our application metrics are still working, right? And thus, if our application metrics die, we still get the logs from our and metrics from our Istio environment. It does add a significant overhead.
It does.
Yes.
Nonetheless, eventually you are going to want some form of scrapable sidecar,
Yeah.
right? Again, which gives you label cardinality problems again.
Yeah, the more you add in, the harder problem it's always been for us. Like it's kind of like a battle of, you always have to kind of look, but at the same time you have to kind of remember you have your day job because I look at active used metrics in our environment and sure, I have 37 metrics that are emitted 10 times in a minute and that adds up to 300,000 metrics. Do I focus on how we manage those or do we focus on the overall value of that? And on top of it, one of the problems that we've had was we started with 2 restrictive metrics. So we had questions of, what do you mean Kubernetes can't tell me how many CPU requests I have? I was like, oh, I guess, yeah, you do want that. Okay, I'll enable it back.
So
Yeah.
the problem is you only have so many seats on the airplane.
Exactly. And
Which metric is getting a seat?
yeah, I mean, one of the strategies I've seen is collecting those at a lower interval. That being said, you as businesses have to make the decision of, can I survive with 1 minute? Some places, maybe yes. A trading firm, probably not. Every second matters in some cases. So again, it matters as to how important that data set or that metric is for your drive.
Could you do some sort of analysis to figure out what metrics, how important the temporal aspects of the metrics are? So are they, find which metric you need to be able to filter on immediately and be able to see in
Yeah.
real time or pseudo real time, and which you could, for example, just dump in
Like a log or
like
something.
a log,
Yeah.
which you then associate with a label called log or something, and then that's one label you're using. That's got a lot of information in that you could then pass later in offline.
A lot of times what I've seen is folks use metrics as in some cases a replacement for logging, which you have to be very careful and understand what is a metric and what is a log. So at the end of the day, the best way I can describe it is metrics are there to give you a real-time status of your application health and tracking of things like CPU, your network, your response codes. But that isn't going to tell you what's actually going on. And that's typically where logging kind of comes in to help elevate that. So I would always say that, I kind of mentioned them, but I always like to look at a few things. We are mostly all writing or supporting applications that are web-based, either GraphQL or APIs. So you typically want to know 500s or 400s or 300s. From there, you want to know, is the problem infrastructure related? So things like CPU, network, and memory all kind of come up. And then ultimately, you want to have application metrics to correlate that. Metrics in themselves are not really valuable. Like looking at high CPU, great. What does that mean? However, if you're able to marry a high CPU to, let's say, all of a sudden random spike in create account or something, you can then say that, well, it looks like there's probably either some sort of a memory leak or CPU leak inside of our environment at this call, because I see CPU increase at the same time this call increases. It's especially really powerful when you're migrating your applications, and it's something that we've used quite heavily, looking at the least performant APIs based on the infrastructure plus the application metrics, and then ultimately going back to logging. Does that kind of, cool. Did anyone on the stream or no? Cool. All right. What's up?
Is there like a sweet spot from the application standpoint? You receive tunnel logs, and sometimes logs are default.
Mm-hmm.
I send you my 6,200,000 to home page. which are very useful.
Mhm.
Is there a way that you guys can guide us to give you the data that is more important instead of flooding with logs?
Yeah. First of which is investing in standardized logging as much as possible. So, you know, a lot of times in libraries, especially early on, folks instrumented in their code the ability to push logs directly from their code, which is great until your app dies and logs are gone. So typically that's where we go to things like, you know, just write it to standard out, and then some sort of library like FluentD will collect it and then push it wherever it needs to go. Structuring your logs in as low format as possible, making them not necessarily human readable. You have a robot in your machine. So making them not human readable, essentially making them JSON logs, and removes a lot of like white space and noise inside of your logging. So then decreasing how much we send, right? But then more importantly, using tools like Fluent, you can then drop specific things or add specific things to your logs. But really, at the end of the day, a platform should be able to scale to the demand of the logs. Developers should be able to turn their logs up when they need it, real time, and turn it down when they don't. So typically, using things like Istio and externalized metrics and logging, you get a lot of that, like with like your AWS, your Google, your Azure, whatever. You'll get that out of your load balancer, but then you supplement those logs and metrics with that additional logging. So typically, I always like to look at how you can roll out a back-end way of increasing and decreasing that knob. It's kind of something that's been in for a while. I know that things like Eureka and the Netflix stack were talked about. Managing, decentralizing your configuration of your applications in some way really is powerful, because then you're able to then, hey, I don't really want to send every 500 or every 200 error. But all of a sudden, that's important. You can turn it all the way up to trace, and then that just starts flooding through. The platform that's deploying to it has to be able to scale to it. Does that help?
Yep.
Cool.
Absolutely. And another question is there like a window of time, speaking of time, and that you observe is more, valuable for certain services? Like, for example, you mentioned real-time trading, of course, there in a second, but real-time trading 5 months ago is useless.
Oh, of course. Yeah.
Is there something that you look for, like a window data that you see very important?
Yeah.
What is it?
Typically, you want to be able to compare at the very least in between your releases. So, you have a release A, release B, release C, release 4. Let's say release 4 times in a month, a major release, pretty common. You want to have at least logs to have visibility as your application is evolving, because then you can say that, hey, at the start of the month, it was 2 seconds to get a response. At the end of the month, it's 1.7. Things are getting better. If it goes up to 10 seconds, something's wrong. So go look at that. Typically, I think it depends. Where I see a lot of trade-offs is kind of what I mentioned actually a little bit with that Fluent slide. Let me see if I can go back to it. Kind of with the same concept of your real-time querying is probably going to happen at the Elasticsearch, separating out your compliance and needs. Like, for example, folks in healthcare, you have a need to query your logs real-time. But you also have a compliance to keep those logs for X amount of years, 2, 5, 7, 8, 10 years, whatever. Especially in financial sectors as well, they have similar compliances. So there's two sides of that coin. So it's almost like the hot side of your query, like how long you want to keep that. That's, as a business, you make that decision. And ultimately the retention side of, hey, I need it. So things like Fluent and OpenTelemetry can allow you to replicate those logs real time, so you get the best of both worlds. You can then say, hey, we're going to keep things in Elastic for about a month. Otherwise, we're going to put them to S3. Worst case, if we have to replay them, we take the logs from S3, ship them back into whatever we use. In this case, it's Elastic, but you can fit that in with whatever tool. Helpful?
Yep.
Cool.
Thanks.
Alrighty. Awesome.
Yeah.
Awesome. Yeah. Thank you. Yeah. Yeah. Thanks everyone. Thanks CNCF. Thanks Christopher for speaking today. Josh, any closing words?
Yeah. No. Thank you all for coming. Thanks for helping us build a community, and hope to see you all next time.
Cool.
Oh, yeah.
Yeah. No, sorry. Thanks everybody. See everyone. Take some pizza. Take some sodas. Take whatever you need. So thank you for coming out and thanks for visiting. Bye.